electric dipole, when we have two charges, let's say Q and minus Q. So when we have two charges Q and minus Q, one is plus Q, one is minus Q, one is positive, one is negative, separated by a distance, let's say the distance is d, but since we'll be using the center point of this distance, this point, so it is better to take this distance as 2a. Why? So that we use a for this and a for this, otherwise we'll have to use d by 2 or a by 2 a by 2. So one positive q, one minus q, separated by a distance 2a. This type of arrangement is called electric dipole. Okay, let's understand it. First of all, we'll understand electric field due to this electric dipole, and later on we'll see how this electric dipole behaves under the influence of an external electric field, that is, if an external electric field is applied to it. Let this be this point. We want to see what is this is point P1. We want to see what is the electric field strength at this point. Now, you know that electric field due to this Q charge, this EQ, this will be away from it because this is positive charge. Let me use some other color so that this is clear to you. This is the line. So electric field due to plus Q is in this direction, and electric field due to minus Q will be in this direction. So E minus Q. What is the total electric field here? Let's see. Let this distance, we'll have to know what is the distance from here or somewhere. So what we do, from the center, let's say this is the equatorial point plane. So from this, let this distance be r. You can take distance from anywhere, but these are conventions, to solve problem. So if from the center point, which center point? That is Q and minus Q, that if the distance is d, center point d by 2. So if from that point, this point is at a distance r, then electric field due to this positive charge EQ, we are talking only of magnitude right now. EQ will be 1 by 4 pi epsilon 0 Q by r square. This will be by r square? No. We have to take distance from Q. What is the distance from here to here? This is r. This is r. This is a. When this is 2a, this will be a, this will be a. So the distance here is r minus a. So this will be r minus a square. Okay. And the direction will be towards out of this. Similarly, E minus Q. This will be 1 by 4 pi epsilon 0 Q. What is the distance here? See, r plus a. So this is r plus a square. What is the net force experienced at this point? You can say this is r minus a, therefore this will be the bigger quantity. So obviously electric field will be somewhere to this side, net electric field intensity. So let's say we denote it as E net. This will be EQ minus EQ. So that is equal to 1. I'll take Q by 4 pi epsilon 0 common. Q by 4 pi epsilon 0, and this will be 1 by r minus a whole square minus 1 by r plus a whole square. Clear? Now let's see how can we solve it. Therefore, electric field will be Q by 4 pi epsilon 0. See this one, r plus a whole square here. So this will be r square plus a square plus twice ra minus this one, r square plus a square, that is r square minus a square, and plus 2ra by this into this. So a minus b into a plus b, that will be a square minus b square. Okay. So this is the situation here. Clear? This is, we take square out of this. So this will be a minus b into a plus b, a square minus b square, then a square. Okay. So this will be what we'll get. We'll get Q 4 pi epsilon 0, r square cancel. You get 4 ra by r square minus a square whole square. Okay. So this is the magnitude of the electric field intensity, and the direction will be to this direction. This is the direction because this is the quantity is higher, the magnitude is higher. This is the situation. Our electric field intensity on the axis, r distance away from the center of the this dipole, is this point. Now let's consider the case when R is very large, that is compared to A. If this be 1 centimeter, R is 10 meters. That situation. What will have? This will be very small. You can neglect A, so this will be R to the power 4. So what will you get finally? The magnitude will be R4 and this is R. So you get Q 4A by R cube. So this is the value of magnitude of electric field intensity if this is, let's say, P naught. So you can take electric field as vector, this into this P cap. This is the direction. Okay, in it is Q4A R cube. Clear? Where when we are taking on the axis, you can take to this point, you can consider at this point, at this point. Okay, so you can take anywhere on this line, only you will have to see the value of this. Now let's see what is the electric field intensity when it is on the equatorial plane. What is the meaning of equatorial plane? Let's see. Equatorial plane means this is the center. If we take this point where this length is R, let's say this length, this to this is R. So we will have, this is a positive charge, so we'll have electric field like this due to this charge, and we'll have, this is minus, so in this direction. Okay, now if you resolve it y direction and x direction, this will cancel out. You know why? If this is theta, this will be theta. So this is EQ cos theta, and this again cos theta. But what about this sin theta? This cancels out because the magnitude of the force is same, the direction is reversed. So y in the y direction will have zero force. For example, if you want to see what is this EQ in y direction, this is 1 by 4 pi epsilon 0 q by, see, q and by, what about this? The length r square plus a square. So this is r square plus a square, under root is the length, we take square of that. Clear? This is what? Root over r square plus a square, and we take a square of this. So the magnitude is this, same magnitude as this. E minus q is also, if we talk of magnitude, same. Now here we have EQ cos theta. This is also theta. Because of this, you can see this is theta. So this is also theta. So EQ, you can see this is, sorry, not cos theta, sin theta. If this is EQ sin theta in this direction, and this is EQ, E minus Q sin theta in this direction. Since the magnitude are same, this cancels out. So whatever we have electric field in this direction. Let's say this is EX. What is EX? EX is EQ in X direction and E minus Q in X direction. Due to this, the magnitude is same, and we have cos theta. So what we have? We'll have 2 into 1 by 4 pi epsilon 0. What is this? Q by r square plus a square. This length and this length is same, under root r square plus a square. Clear? Cos theta. What is cos theta? See, theta is this. So cos theta will be a by root over r square a square. So cos theta is a by root over r square plus a square. So if you put it here, what you will get? You will get r here, sorry, a here, and this will be, this is 1 and half. So this will be 3 by 2. So I'm rubbing cos theta. You understand what is cos theta? So finally what we get? We get 1 by 4 epsilon 0 2qa by this. So this is the net electric field intensity due to this charge, and this will be, if the position vector is, we had taken p to this side, so this will be minus p. Okay, or you can understand this is in x direction. Since we had taken p in this direction, so x is minus p. Clear? Now if r is very large compared to a, as we saw there, if r is very large to a, what we will get? This will be r square, so r cube. So your E net magnitude will be 1 by 4 epsilon 0. This is 2qa by r cube. Okay. So if you have values given, r, a, everything, you can find out electric field intensity. But here we'll define a new term. and what it is. This term is q into 2a. Just try to see there. When we are considering on the axis, it was 4qa. So you can say 2 into q into 2a. This term is called dipole given by p. And it is a vector. Vector, the direction is because of a. Okay. So q into a is the dipole moment. Okay. A better way to represent it like this. A vector which is q cross 2a. These are scalars in the direction of p. So this is your dipole moment, defined as dipole moment. What is its significance? The significance is, if you talk of molecules inside a structure, they are generally plus and minus charges, and if they have a distance, that creates a dipole moment. Generally this distance is 0, therefore the crystal structure is neutral. But when you have a gap, and when you put, or in some materials, when there is a gap, there is electric dipole moment. It remains like this. Okay. But if an electric field is applied to it, what will happen? Let's understand. See, if this is your q and this is your minus q, if we apply electric field, what will happen? We'll have F in this direction and F in this direction, or electric field in the direction is this. So force will be in this direction due to minus charge, and in this direction due to plus charge. So you see, it behaves like a moment. Okay. So if it is with respect to this, if it is at 90 degrees, this combined system won't have any, won't experience any force or any torque. But if it is, deflected a bit like theta, what will happen? This will pull it and this will push it. So you'll have a torque. So P is Q2A. You understand? What will be the torque if this is at an angle theta? Torque will be, it is also a vector quantity. It is P, that is your dipole, cross electric field E. That is, it is cross product of this. Or if you want to see the magnitude, it will be P cross PE sine theta. Okay. The cross product is P sine theta. So this will be the torque experienced by this combined system, this dipole, if this dipole is placed in an external electric field. Clear? And you see, this is sine theta, this is theta. When theta is 0, torque is 0. So the net effect of this torque is to align the dipole to its original position, so that theta becomes 0. Clear? Again I am saying, if this is aligned to theta, that is, if it was original in this direction and E was in this direction, it somehow we displace it to this thing, theta, at an angle to theta. Then a torque is created. What is the significance of torque? The torque will try to align it again till theta is equal to 0. So if you pull it like this, this new torque, because of this electric field, will pull it to realign to 0 theta. Okay, this is the meaning of theta. Torque. Now we'll see examples on electric field dipole, and we'll see some example where we'll see how this torque actually realigns the dipole alignment. So up till now, what we have learned about dipoles. Just giving you a quick recap with the variables so that we are able to see new concepts. We saw if this is, let's say, minus q and this is plus q, separated by a distance, whatever you call d, or you can say 2a, this is a dipole. You know this. If it is, the direction of the vector, the vector is taken as p, is this, which vector? Dipole vector. So the direction is from minus to plus. These things you should keep in mind. Minus q to plus q, the direction is p. Minus q to plus q. So the electric field on a point that lies on the axial plane. Axial plane means the line joining the two charges. The distance between them, we have seen the distance between which the center point to that point is r. We have defined this. So the electric field is given as 1 by 4 pi epsilon 0 q by r cube p cap. Sorry, not p cube, p 2p because it is on the axial plane. And if we talk of equatorial plane, and if it lies on the equatorial plane, that is this line from the line from the center of the distance between these two charges, then the electric field is given by 1 by 4 pi epsilon 0 p by r cube p cap. Okay, so this is the electric field due to dipole. This you should keep in mind. I should write this as axial and this as equatorial. Okay, this is important for you to keep in mind. Now we will revisit the torque due to a dipole. Let's understand it with some fresh perspective. Let us draw like this. This is your electric field in this direction. Okay, let this electric field be E, and let the dipole be like this. Okay, let me take the red color. So dipole is at an angle, let's say theta. So this is also theta. This is your plus q, this is your minus q. So p is in this direction. Okay, this is p. P is this, p cap. So what is torque? Torque is the force into length from the actual length perpendicular to this, that is force is in this direction for plus q and it is in this direction minus q. This force is, let's say, force due to E. Okay, this is also force due to E. This, what is the value of this force? This force Fe, let's say this is E minus and E plus for q charge and minus charge. These two forces are actually equal. Magnitude of these two forces are equal. Why? Because Fe, this F is basically q into E, both. So the magnitudes are equal. When magnitudes are equal, net force is 0. This is in this direction, this is in this direction. Magnitude of the two forces are equal, so net force is 0. But what about torque? Torque will be, if we consider this force, then F into the perpendicular distance in the direction of electric field. So it will be like this. This into this. This will be the torque. What is this length? This is theta, and this is your, let's say the length is d. So this is d sine theta. So torque is Fe d sine theta. This is clear. What is F? It is q into E into d into sine theta, or q into d. This charge into d. What is this? This is p. So this is p e sine theta. So your torque is, the magnitude of the torque is p e sine theta, or in vector form, what you can write? In vector, tau is equal to p cross E. This is the definition that I had told you. Clear? You should have clear understanding of this. What will be tau max? Tau max you'll have when theta is equal to 90 degree. Tau max at theta equal to 90, because sine theta can be from -1 to +1, and +1 you have at pi by 2. So at theta equal to 90 degree, that is this, it is perpendicular to this. That is when your P is perpendicular to electric field. So when your dipole moment is perpendicular to the electric field, the torque will be maximum. And what will be tau minimum? Torque minimum. This is when theta will be 0. So at theta equal to 0 degree. What is the meaning? Theta 0 degree. That is, it is parallel to, that is when P is parallel to E. Okay, parallel to E or anti-parallel to E, 0 or pi. For both values, sine theta will be 0. So either it is like this or it is like this, it will be minimum. This is the concept associated with dipole. Let's see 1-2 examples to understand this. So this first example is what we just discussed. It says we have an electric dipole in an electric field. we have to diagrammatically show when torque will be maximum, when torque will be minimum, that is 0, and when torque will be half of maximum torque. So you know, if again I am drawing the same diagram, the diagram that we had just put on the board. Let this be your electric field. This is the direction of electric field. Okay, and this be electric dipole like this. The first question says when it will be maximum. You know it will be maximum when it will be perpendicular to, when P is perpendicular to electric field. So this is the situation when your torque will be maximum. So I am writing tau max here. Clear? And what will be the value of tau max? It will be P cross, not cross, P into E, because sin theta is 1. This is tau max. The second part is when will be torque minimum. You know it will be minimum when it is parallel to this, like this, minus Q plus Q. When your P is in this direction, parallel or anti-parallel to this, it will be minimum, and the minimum value is 0. That is theta is 0 over pi. Next part is what will be the position when tau is equal to half of tau max. When it will be half, see, we know tau is equal to Pe sin theta. Half means this has to be half, and when is sin theta half? Sin theta is half at theta equal to 30 degrees. So this is half of Pe at theta equal to 30 degree. That is half of tau max. That is when it is like this, minus Q plus Q, this angle is 30 degree. When P is like this, it is half of the maximum torque. Clear? Now, the question says we have charge equal to 0.1 microcoulombs. We are talking of an electric dipole. That is, it will be like this. Let's say this is minus Q and this is plus Q. Q, the value of Q is 0.1 microcoulombs. The distance between the two is 2 into 10 to the power minus 3 meters in SI units. An electric field of 10 to the power 5 newtons per coulomb is present in this we should say the dipole is placed in an electric field of 10 to the power 5 newtons per coulomb. What will be the maximum torque? We know we have maximum torque when P, that is, this is your P is perpendicular to electric field. That is, when electric field be like this, this is your electric field, then only we will have maximum torque. And what is the value of that maximum torque? Pe sin theta, theta equal to pi by 2, so it is P into E. Simple. And what is P? P is Q into D. So Q D E, we are talking of the magnitude. So Q is 0.1 microcoulombs, 10 to the power minus 6. D is 2 into 10 to the power minus 3. And electric field is 10 to the power 5. Okay. Newtons meter, this will be in Newtons meter. See, coulomb will, this into this, so you'll have Newton, and into this we'll have meters. So this is what? This is 2 into 10 to the power, what will be the value? See, this is 10 to the power minus 7. So minus 7 minus 3 is minus 10 and plus 5. So minus 5 Newton meter. This is your torque. Okay. So we saw the behavior of an electric dipole in an electric field. What type of electric field? Uniform electric field. When we said E, like this is E. This was uniform electric field. That is, everywhere it is same. What if we have non-uniform electric field? Let's say the electric field is, the strength of the electric field increases to this side. Okay, if we have such an electric field, let this be E. But this is a function of distance. If this is your x and y, then along x, the electric field is a function of this. Then the important thing to note here is that the force experienced by the dipole, if a dipole is placed here, okay, minus Q plus Q, in this type of field, which is not uniform. It is increasing spatially. So in that case, F is given as P, that is your dipole, into dE by dx, and we are talking of magnitude only, because if we talk of direction and everything, this will complicate. So this is dE by dx, mod of this into mod of this. That is the gradient of electric field. What is dE by dx? Gradient of electric field. You have E as a function. Let's say the electric field is given as 7x square. Okay, the magnitude. So the gradient will be dE by dx will be 14x, and then you have to multiply it with P, whatever P you have. When you multiply it with P, you will get the force experienced by the electric field, the magnitude of force. Okay, so this is a very important concept. Why? In the starting only, when we defined charge, or whenever you talk of you start with electricity, you start with electrostatics, you have an example that when glass is rubbed against silk, you get sparks, or if you have pieces of paper that will get attracted towards the rod. This is a very common thing that you experience. Why? This is to be understood. See, if we have a charged rod, it means it will create electric field. Okay, so let that electric field be this. Undoubtedly, this electric field will be non-uniform. You cannot have a constant electric field. Why? Because if this is the rod, this E will vary from here to here. How? Inversely proportional to the cube of the distance. So this won't be a uniform electric field. So we have what to say, we have dE by dx, we have gradient, spatial gradient for the electric field when a glass rod is charged. Okay, now in that field we put some small pieces of paper. What happens? Let that paper be this. What happens? We have molecular dipole moments because of this electric field. That is, dipole moments are created inside this structure because of this electric field. Okay, now the effect of this dE by dx is that the dipoles are attracted towards the stronger field side. If this is stronger field side, the dipoles will have an orientation to get aligned to this side. They are attracted towards this side, the stronger field. Repelled, not repelled, but attracted towards the strong field. Clear? The meaning of physical importance of this gradient is that if a dipole is placed in this, it experiences a force towards the stronger field, the side of the field or the area of the field, the direction of the field. The best way is to say the direction of the field where the field is stronger. So this gradient into this is equal to this force. If you have a charged glass rod, that is, you have rubbed it against silk, it is charged. Now when paper pieces are brought closer to this, the molecular, we have molecular gaps inside them. So this field, this non-uniform field creates electric dipole moments inside the paper. Because of the gradient, this dipole, these dipoles get attracted towards the stronger field side. So what happens? These, because they are very light, they get attracted towards the glass rod. They get to stick to the glass rod. Clear? So this is the concept. Let's see an example to understand it. Let's say we have two dipoles. One is this, P1, okay, and we have another dipole, P2. The direction is this. We have to find what will be the force experienced by this dipole. Now understand, these lie on the axial plane. Okay. Now you know that electric field, this due to this first dipole, this is equal to 1 by 4 pi epsilon 0 P1 by R cube. R cube will be this direction. If this is center, then this is R. If this is the point P, this is R. So this is R cube in the direction of P1. This is your electric field. This you know. Now you can see this is this dipole is creating a non-uniform electric field. The electric field is the strongest at this point and then it slowly decreases. So this is a non-uniform electric field. What is the gradient? Electric field gradient E1 with respect to, let's say we have R. So R dE by dr, this is the gradient. What you will have? You will have 1 by 4 pi epsilon 0 This will be P1 by R to the power 4 P1. Okay, we have differentiated it. And this will be 3 R to the power minus 3. So this is minus 3. This is the electric field gradient experienced by P2. Okay, one thing I forgot. See, this is 2P. It is on the axial plane, not on equatorial. If it was on equatorial plane, this would have been P1. This is an axial plane, so 2P. So this is 2 into 3. This we can write like 6. So this is d by dr. Now what is the force experienced by this? I told you, let this force be force. The magnitude will be P. That is P2. We are talking of P2, the magnitude, into this. That is, if you talk of magnitude only, it will be like this. So the force experienced by this dipole is this much, and you know this is stronger at this point, so this dipole will be attracted to this dipole because of the non-uniform electric field. I think you have understood it. If you get a problem in numbers, you have R as 2 millimeter, P as something, and dipole moment is given, you can find the value. I have given you the concept. Okay.